In this seminar, we will learn about isothermal and adiabatic process. There are 4 types of thermodynamic process. They are isothermal, adiabatic, isochoric and isobaric process. Now we learn about isothermal and adiabatic process. In isothermal process, the temperature remains constant, but the pressure and volume of the thermodynamic system will change. We know that ideal gas equation, that is PV equal to mu RT. We know that the mu and R are constant. In isothermal process, the temperature is also constant. So PV equal to constant. In constant temperature, the internal energy of the system is also constant. So the internal energy of the system is 0. Now we see the isothermal expansion and isothermal compression. In isothermal expansion, the pressure decreased with the increase in volume at a constant temperature. Consider a piston which is maintained at a constant temperature T. When the piston was moved upward, the pressure decreased and the volume was increased at a constant temperature. This graph clearly shows that the pressure was decreased with the increase in volume at a constant temperature. This is called isothermal expansion. In isothermal compression, the pressure was increased and the volume was decreased at a constant temperature. Consider the same piston. Now the piston was pushed downward. The pressure was increased with a decreased volume at a constant temperature. This graph clearly shows that the pressure was increased with a decreased volume at a constant temperature. An example for isothermal process is refrigerator. There are many processes happened inside the refrigerator, but the temperatures remains constant. So fridge is an example for isothermal process. Okay, now we learn about adiabatic expansion and adiabatic compression. In adiabatic expansion, both pressure and temperatures are decreased and the volume is increased. Consider a movable piston. When the piston was moved upward, pressure and temperatures are decreased and the volume is increased. This graph clearly shows that the pressure and temperatures are decreased with the increase in volume. This is called adiabatic expansion. In adiabatic compression, both pressure and temperatures are increased with a decrease in volume. Consider the same movable piston. When the piston was moved downward, the pressure and temperatures are increased and the volume is decreased. This graph clearly shows that the pressure and temperatures are increased with a decrease in volume. This is called adiabatic compression. An example for adiabatic process is thermos flask. In thermos flask, the exchange of heat between the system and the surrounding is minimum. Finally, we see the difference between the isothermal and adiabatic process. In isothermal process, the temperature remains constant, but in adiabatic process, the temperature change within the system. In isothermal process, the heat transfer can be observed, but in adiabatic process, there was no heat transfer. In isothermal, the temperature is constant, but in adiabatic, the temperature is changed. In isothermal, the work done is due to net heat content of the system, but in adiabatic, the work done is due to change in internal energy of the system.